So here is chassis number 3, or monitor number 3 of 4 for this same person out of Kansas City. And obviously it's a Hantarex Polo, 25-inch, all original. This came out of a Revolution X, and it has vertical collapse. I'm also told that they think it has a color problem too, because when you look at the the horizontal line, it looks like some of the colors are missing, but it's kind of hard to tell. Anyway, so let's go ahead and turn it on. I have not turned it on yet. We'll verify the discrepancy and then see if we can figure it out. So let's go ahead and turn it on. I haven't turned it on yet. Let's see what happens here. 1, 2, 3. Oh, it comes right on. Kind of got a high-pitched noise to it. Do we have collapse? Well, yeah, we do. Oh, gosh darn it. That's a bummer. I don't think there's missing colors. When I turn the brightness pot, nothing seems to happen. It's odd. It's all the way down, all the way up. Contrast down. Okay. Well, yep, it's collapsed. Let's take it apart, inspect some items, and see what we can find. Alright, so here we have the chassis demounted from the monitor, and the first thing we want to do is give it a really good visual inspection. Always do a good visual inspection. Look for burnt components, look for broken traces, bad solder joints, the whole 9 yards. So if we just look here, I'm going to just give this a good cursory look. Just do this in real time. I'm looking for burnt resistors or anything that just looks odd or out of place. Maybe a broken diode, a bent component touching something else that it shouldn't be. You know, you'd imagine that this was working until it wasn't working. So I'm not really too concerned about bent components, so to speak, as I am something that looks visually burned. I don't see anything immediately. It all seems okay. Let's take a look over here. Well, I stand corrected. These resistors have been bent flat here. They should be sitting up. You can see how they're kind of, if we zoom in here, you can see that the leg is bent over and the leg is bent over. It should be like that. That's how it should be. And then this one is bent over as well. Like that's how it should. Somebody smashed those. All right, let's look at the bottom side. Now there's a cover here we have to take off to inspect this fully. Take this cover off here. It's held in with 2 screws and 2 little snaps that just kind of unsnap. Set those aside, and then this should just come right off of here like so. Okay. There's these 2, let's see, this post and this post here. These 2 posts right there. I'm zoomed in too far. These 2 right here, they go into, where's it at? I need to basically put this back on. There we go. So there is a little, not that it matters here, I just want to show it. There's 2 clips that those clip into. Why am I blind? Okay, because they're on this side. Here they are. There's a little holder clip right here on each side. This little tab here, right there, will go up through the bottom of the board and just kind of clip into there. So there's 2 clips, one there, and then there's one back over here somewhere that these will clip into. So that's how it is. It's just the 2 screws and the 2 clips. Okay, so now we can go ahead and just take a look at this. I'm just going to look at it the way that it is here, and if I see something, I'll zoom in on it. There's a giant scratch across here that shouldn't be there. There's a giant scratch across here, but it doesn't appear to have gone through any traces or anything. It's just kind of a surface scratch. I'm looking for cracked joints in the power supply section, or bad solder joints. I don't see anything yet. Anything hiding up in there? No. So far, so good. Power connector, they're a bit rough, but they're okay for now. Switch mode power supply chip that's in there, it seems okay. I don't see anything that's leaping off at me. Oh, I see something. I see something. And look at that. It just so happens to be on one of our smashed flat resistors. Look at this. Now, I don't know if this is our problem, but if we look right there, we've got... come on, you dumb camera. There we go. Look at that. Wow. Busted trace right off of our resistor that got smashed flat. And, yep. Look at that. Let's get that fixed. I mean, wow, it even damaged the plastic next to it. Look at, wow. Huh. It even busted that plastic. That's insane. That took a hard hit somehow. Wow. Well, let's get that fixed. And then we'll see what we can do here. I think what I'll do is I'll fix this. And then I'll just cut the camera and I'll do a full complete reflow. I'll fix that. We'll show that on camera. We'll fix that on camera and then I'll do a full complete reflow like I always do since I have this upside down and out. And we can eliminate that as a possibility because if this doesn't fix it, we'll do the full reflow. Well, I take that back. We're not going to know if this fixes it. If it's a solder joint problem, and I fix this, we don't know if, and I turn it back on if it works. I don't know if it was a reflow that fixed it or if it was that. But I looked over this. I don't see anything like this anywhere but right there. I don't see any cracked joints, or especially usually you can see cracked joints here in the power supply section. Sometimes this area here gets cracks. So I don't see any bad solder joints anywhere after looking over this. The only thing that I have noticed or seen is this. So I take that back. Let me fix that, and then I'll just fix that, and then we'll see what happens. Because I don't want to be left with the uncertainty of whether it was the reflow or whether it was that fixed it. Now I don't know if that'll fix it. I don't know if that's part of the vertical circuit or not. I'm too lazy to look it up. But you know, I originally, you know, I record here on the fly. I don't have a script. I just go off the cuff, and I was thinking that I would repair this and then do a reflow and see if it worked. But in hindsight, after saying that, hearing myself say that, I realized, well, that's kind of stupid because if I fix this and then reflow it and it works, I don't know if it was the reflow with a bad solder joint or I don't know if it was that fixed it. So let's fix this, then test it and see what we have. Because, you know, like I said, I don't see anything else that leaps out at me of like, oh, there's a cracked joint, there's a cracked joint, things like that. So let's get this fixed. Can I get this thing out of here? No sooner do I ask than I do. That should be good enough. That should be good enough. So let's see what we can do about this here. Wow. I doubt that I'll be able... Let me turn my fan on here. I doubt that I will be able to work some magic here with the fiberglass pen. Oh, maybe so. Look at that. That might help. Well done, stout fellow. That one's proving to be a bit more difficult here. But that should work. Okay. So let's work some magic here. Oh, you gotta turn the iron on first, you dummy. Alright, I'm gonna cut away here, let the iron heat up, and I'll come right back. Actually, while I'm waiting, I noticed here that right up against the joint we still have some solder mask over the trace there, so I'll see if I can't get that to expose itself there. Now I'm gonna rip the trace. I've already ripped it. Well, that should be good enough. Let's move this over a bit. There we go. I mean, that should be okay for what we need to do here. And we're already at 800 degrees, so here we go. Let's reflow this. All right. Booyah, look how easy that is. Let's go to this one. And we're putting too much on there. That one doesn't want to jump that one doesn't want to jump over. Is there too much of a gap there? Yeah. Yeah. There we go. Got it. And there you have it. That should work out just fine. Not beautiful, but it works. So let's how about this other joint here? This other joint seems okay, but we're gonna hit it anyway for the other side of the resistor there. And then let's check this other one that was bent back here, and it's intact, but we'll hit that one as well. Okay, well, let's see what that did. We'll cross our fingers. If not, we'll come back and do a bit more troubleshooting. Put that back in there. And get my cover plate back on here. Alright. This should just snap right in. There we go. Get our screws back in. And I think just in case this works, I want to talk about a few features of the Polo here before we hook it up. Okay, so let's say this one's notorious for having vertical linearity problems. You'll see where, like, if you're looking at the top half of the screen, it's stretched, and the bottom half of the screen is squished, and it doesn't have uniformity for your vertical. There's an adjustment right here, vertical linearity. If we zoom in and look at this, you can see here that it says VLIN. That's vertical linearity. So if you have an issue where if you're looking at the screen and the bottom half is squished compared to the top half is tall, you want to adjust that linearity pot to compensate for that. We may end up having to do that. So that's, you know, and of course it's right here next to your vertical IC, which is this guy right there. So if this works, I'm going to have to probably do a cap kit and a flyback and a full reflow. I have all this stuff on hand and a better inspection, but yeah, I think that I'm confident that this may not fix the problem, but at least make it better, if you will. I can't say. So yeah, let's get it hooked back up and see what happens. And of course, off camera, before I did anything, I unhooked all this stuff. So I'll get this all hooked back up. And we'll turn it on and see what we get. So stand by. Okay, all hooked back up, ready to go. Let's turn it on and see what we get. Fingers crossed here. 1, 2, 3. Okay, it comes right on. It's got a high-pitched noise to it. That can make go away when I do that. Shit. It still collapsed. Brightness contrast all the way down. Flyback. Oh wow, the flyback is all the way down. Brightness contrast all the way down, and look how bright that is. Holy cow, something else is very wrong here. Well, this was definitely an issue. We have, listen to this. I can make that noise go away by. That is super weird. Makes no effect on the image, but. Okay, well, we got more testing to do, more in-depth research. Let's see if maybe a full reflow and a full cap kit. I'll change the flyback, do all the rebuild stuff, and I'll test some other components. And we'll see if we can get this thing working again and see what we can find. So, stand by. Well, we're back here, and I've decided to do a little bit of a game plan change. I originally mentioned here just moments ago that I was just going to do a full cap kit, reflow, and flyback and see what happens, but I decided to not go through that trouble just yet. I wanted to see if maybe there was something we could find before going to all that trouble. So I reached out to the great sage-like George Spanos, who is the Polo Whisperer. He's got, as good as I am with the Wells Gardner stuff, he's that good with the Polo stuff. So I've only actually maybe worked on 2 or 3 of these in my lifetime, because almost every machine or game I've ever come across, acquired, worked on, had a Wells Gardner in it and not a Polo. These are a bit more hard to come by, because when they fail, people just ditch them and put a Wells Gardner in, because they're hard to work on, hard to fix. And so I don't come across these very often, maybe 2 or 3 or 4 in my entire lifetime of working on machines. So I don't have that much experience with the Polo. That's why you haven't seen me work on these really on the channel before. This is the first one, because I just don't really have the knowledge to fix these. But, you know, with anything, how it all goes, the more you work on it, the more you learn. So I'm trying to get this stuff done here, and maybe I'll feature more Polos here on the channel in the future. But for this instance, I reached out to George, and he gave me a list, 3 or 4 things to check. And the first thing he suggested was R167. So I have a donor chassis here. This one's kind of been picked clean. The cage is gone. All the stuff is gone. Oh, well, I didn't show it, but I removed this cage here that sits over the power supply section. The filter caps are gone. HOT is gone. This one's just kind of become a parts chassis. So if we check R167, it's not really a resistor. I mean, it is, but it's more of a fusible link. So R167 is this guy right here, right there. So it's supposed to have continuity across it. You can actually see that this one's even burned up. This resistor's burned up. That's partly why this thing became a parts chassis, is it failed miserably. Or failed spectacularly, whatever you want to call it. When these work, they look fantastic. But when they fail hard, and people don't work on them. So it's a mixed bag of emotions with these Hantarex Polos. But regardless of this burned up resistor, R167 is right here. And if we test it for continuity, it should have continuity. And it's basically a fusible link that supplies power to the vertical IC here to allow for vertical deflection. So if this is open, we're not going to have any voltage getting to our vertical IC for our vertical deflection. So if we test it here on this donor chassis, you can see I got my meter, continuity mode. We test this one, and it's good. Good continuity. So let's go to our bad chassis here with the collapse. You can see this one's a bit beefier, but if we test this one, open, 0, out of limits, 0, OL. If I go to ohms and touch it, it reads 2.2 megohm, 1.8 megohm. Yeah, it's shot. So we're going to replace this and see if that fixes our problem. If this fixes our problem, we'll go ahead and do our full reflow, cap kit, flyback, and do final testing. But if we replace this and does not fix the problem, there's some more components we'll go over and check afterward. So let's get this replaced and then see if that fixes our collapse. If so, we'll finish our work and call it good. If it doesn't, we'll continue on with some other stuff to check and we'll see. But yeah, that's the first thing that I tested and the first thing that I found, and it was failed. So I'm gonna get that changed out and then we will see what happens here. So stand by for a moment and I'll come right back and we'll have it changed out and we'll test it and then see. So I have successfully replaced the R167 from the donor chassis, and we can test it here and get out of the way, you stupid ribbon cable. And if we test it here, it's now good. So the other items I figured I would go ahead and talk about is that George had mentioned that if R167 was actually good, the next thing to test would be R177, which is this resistor right here. And if we test that one also tests good. So it's either going to be R167, R177, and if those test good and you still have collapse, it's almost surely a bad vertical IC. And you can test that by going to ground. There's 2 pins that check to ground. Let's see here. Vertical IC here. Yeah, see? So if we go to ground, I'm just touching the ground here, the ground plane. So there's 2 pins to touch ground. There's this one and this one. So 1, 4. I don't know if that's 1 and 4, but you just look at it this way. There's the first one and the fourth one. Those test good to ground, and the rest of them don't. Now I've compared that to this one over here, the donor chassis, and it's the same way. So yeah, if you have any of the other pins bring to ground except those 2, the vertical IC is pretty much shorted. So yeah, those are the other options, the other suggestions that George had. The last one, I guess, would be cracked solder joints around the main transformer here. But for the most part, yeah, it's those R167, R177, and the vertical IC are pretty much the 3 main components that would cause vertical collapse on this. Kind of like on the 7475, 2000, 5000, the R303, D302, and D603. If any of those are bad, it'll cause it, but if those are good, then it's usually the vertical IC. Same type of situation here. So with that being done, I'm not going to do a cap kit and a flyback and a reflow just yet. I want to just hook it up real quick and see if that R167 being open fixed our problem. So I'll get it all back together, back on the tube, and I'll come back and we'll see what it does. Alright, we're all hooked up again. Anode, neck, yoke, ground, video, power, remote board. Everything is secure. So let's see what happens. 1, 2, 3. Uh-oh. Uh-oh. R167 is smoked. We got smoke coming off. And now it's got a little bit of a black mark on it. Well, that's not good. Does it still check okay? I don't know if I'll be able to do this. Can I do this here successfully? And it's open. God dang it, what the heck? Huh. Wow. Well, something is very wrong then, because it just smoked it as soon as I turned it on. Wow. Well, back to the drawing board. I guess we'll see what I can find this time. Actually, I got a wild hair here. I'm going to perform a little experiment. Do not try this at home. Just, I want to see what happens here. So we can see we're still collapsed. I have a jumper wire here. But I'm just going to jump this resistor, this R167. I'm just going to jump it. I'm going to tap this and just see if we get full deflection when I tap this here. So if I just tap this here, let's look at, I'm going to watch this to make sure I don't touch something I shouldn't. I'm going to tap it. Now let's see what happens here. Hey, full deflection. Can I zoom out? Let's zoom out. There we go. So I'm going to tap it again. Full deflection. Look at that. Wow. Okay, so now we know that it works and we get full deflection, but there's something else going on that's causing that to burn out. Maybe it needs to be a bit, the other one was beefier than this one. Maybe the fact that this one's a bit smaller, a little lower wattage, that very well could be. I probably made the mistake and put a much lower wattage one in there, but it came off of another Polo, so maybe there was a modification or a different revision, I can't say. But with that one being such a smaller wattage than this one, yeah, that could be the issue. So maybe I'll need to find a bigger wattage one to put in there and see what happens. But we just proved theory of concept, or concept of theory, however you say that. We jumped it and we got full deflection. So obviously nothing else is wrong. So let's go ahead and see if we can find a bigger wattage one with the right rating and put that one in there and then see what happens here. So stand by. All right, so the original R167 is red, red, gold, gold, which is 2.2 ohms. And it's supposed to be, the schematic calls for a half watt, which is what this basically was, a half watt. And for some reason, I think someone put a 2 watt one in this one. So I went and found another 2.2 ohm 2 watt R167, and I put that in there. So let's test it now. We know that the system works when we jumper it. So in theory, it should work with the higher wattage one. So let's find out. 1, 2, 3. Okay, comes on. No smoke. What do we get? No smoke. Hey! All right. Why don't we have an image? Brightness and contrast are all the way down. Why is the screen all white? Wow, our flyback is all the way down. Brightness and contrast all the way down. And we have nothing but a white image. We have our full deflection now. Why do we only have a white screen? Test video selection is off. Horizontal, yeah, video amp, that's vertical amp, we don't need that. Brightness contrast all the way down. The screen pot on the flyback is, if I turn it up, you can see that it gets brighter. Well, maybe you can't, it's stupid. Yeah, see, there's our raster lines. That is with the flyback all the way down. Huh. Interesting. Vertical hold, horizontal hold, width, or vertical position, horizontal frequency. Huh. Why? Well, further troubleshooting is required. Stand by. Okay, further troubleshooting has revealed that it's most likely the, let's see, the LM1203N chip, the chip that's on the neck board. And this is the donor chassis. This is the one that we're working on. And I have no brightness control, no contrast control, and none of the color pots do anything. If I turn up the red, green, blue pots, nothing changes. So the theory here is that we have a bad LM1203 November chip. Now this is the one off the donor neck board. So if we test the one that's on the suspect board here, you can see here that we have a pin ringing to ground that most likely shouldn't be. If we go to ground here, actually, well, I'll just show you. Ground to pin 4 here. 1, 2, 3, 4. This pin here, 1, 2, 3, 4. This pin reads 57 ohms to ground. And it shouldn't be, in theory, because it didn't read 57 ohms to ground on this one. It was like 300 some odd ohms to ground. So I think we got a bad chip here. And I probably should have gone on the overhead, but if we were to zoom out here and hold this on here and touch pin 4, you'll hear 1, 2, 3, 4. That's 57 ohms. And I think
this here should be the only ground, because that's 0. That's 0 ohms, right to ground. But if we go to this pin, that's 57 ohms, and I don't think that should be going to ground. So we're going to change that chip out, take this one out, put this one in, and we'll see what that yields. So hang on 1 second. Alright, so a few hours have passed since I last left you. I think I actually left you with a all white screen, and brightness contrast made no change, and the flyback completely down, still had an all white screen. So I did a little poking around, and I thought maybe that this RGB chip was bad, this LM1203 November. I thought maybe that chip was bad, so I replaced it with one from this board. This chip here was originally on this one, and I turned it back on after replacing it, and it did nothing. I still had an all white screen, no brightness control, no contrast control, nothing. Flyback all the way down, still white, not the way it's supposed to be. So I put the original chip, knowing that it was fine, into this board, and then I put this board on this chassis, disconnected all this stuff, and hooked this board up to this chassis. When I turned it on, my white screen was gone. I had no image, but the white screen was gone. Brightness and contrast control still had no effect. When I turned the flyback up, because it was all the way down, and I started to get a picture, it still did not have a game image. It was just a partial white screen with a couple of lines on the top of the image. And as soon as I turned the flyback up slightly, I saw that momentarily on the screen, just a bottom white screen and some lines on the top. Zap, the monitor died, and it began ticking, tick, tick, tick. And the HOT died. HOT went out. So I put my preferred HOT in there, the FJL 6920, and I put the original neckboard back on, and it fired right back up. But we were met again with an all-white image, brightness, contrast, no control, flyback all the way down, still white image. So we're back to square one, and I just started scratching my head, wasn't sure what to do. So I began by I was going to say, okay, I'll do a full cap kit, flyback, and a reflow like I always do, see if that makes a difference. But I thought, well, hang on a minute. I got the flyback out, and I started thinking, well, now wait a minute. Let's just go ahead and check the neckboard, because we had different things happen when I changed the neckboard out. So I started poking around, testing various components, and here's our 3 color transistors and our color resistors. And I tested R40 here. As you can see, R40 is out of circuit. In circuit, it was reading way out of tolerance. It's supposed to be 10 ohms. This resistor here is, let's see, it's brown, black, black, gold. It's supposed to be 10 ohms. Well, wouldn't you know it, when I tested it, it did not read 10 ohms. I have it sitting here. I got my red and my yellow leads attached to it, and red and yellow leads here attached to my leads for my meter, and look at what it reads. 7.3 megohm. Wow. That's quite a far cry from 10 ohms. So I am going to do the full cap kit, the reflow, and the flyback replacement. And I'm going to steal this 10 ohm resistor out of this neckboard and put it in here. And then, fingers crossed, that should be the issue. If not, it's definitely a contributing factor. So let's get all that work done, get this changed out, and then we'll test it again to see if it's any better or any worse, and where we're at from that point. Well, we fast forward a couple of hours here and making progress, but we're moving forward and we're going back. I don't have my mat here because I'm in the process of constantly going testing, untesting, testing, untesting, chassis on, chassis off. But a couple of things here. I did a full cap kit, full reflow, and I changed out the resistor here, the R40 that I had talked about, and now it reached 10 ohms, so everything is good. So I tested it, I changed out the R40, it still had the all white screen. So then I did the full cap kit, full reflow, and new flyback, hooked it up, still the white screen. So I did some more poking around and testing, and I found this resistor here, R335, I think it was, R235. R235 was another resistor that was open, that resistor right there, and the one I took out is right here. It was open, just like our R167 was open. This was the original cause of our vertical collapse. But after we fixed that, we saw we had the all white screen. And then I found R40 on the neck board, reading 7.3 meg ohm. So we changed out R40 and tried it, still the white screen. So I did a full cap kit, full reflow flyback, checked it out, still white screen. Then I found this R235 open, right here by the horizontal output transistor, HOT. Changed that out, and now it reads properly, I think 17K or something. Checked and tested it, still a white screen. So that's where we're at right now. And then I noticed doing some testing that IC105, this guy right here, IC105, I have removed it. This is the power MOSFET that changes 12 volts to 15 volts for our video B plus signal. And then it goes off to the neck board. So I found out that most likely what's happening is this chip here for the RGB processing for the video encoder, basically is what this is. I haven't tested it, but I think it's missing 15 volts because this is the MOSFET that changes the 12 volts to 15 and sends it out to the neck board to this chip. And I say I think it's missing because if we actually test this, we can see when I first tested it in circuit, it was reading shorted. And if we go to there, so now if we just go to our transistor here, we can see that if I test this out of circuit, we go to this leg, we're 0.5 voltage drop, the other leg, 0.6 voltage drop. So we have voltage drop on each side the way that it's supposed to be, just like this. In circuit though, when this is actually in circuit, and we read it across these two pads here, you can see here that it reads shorted. Not shorted, I guess, it's like 100 ohms across the middle one, and this outside one, it's 100 ohms or so. So something is wrong because in circuit, when you read this, it reads shorted. So I took this donor chassis and tested this one. If we test this one, you'll see here that this one actually reads the way it's supposed to. If we go to this outside leg, come on, there we go. There is our voltage drop, 0.5, other leg, 0.5, well, 0.428. I just round up to 5. So voltage drop on the left leg to the middle and voltage drop to the right leg in the middle. But if we go to this one that we're having a problem with and we do the same thing, right leg to middle, voltage drop. We don't have the MOSFET in, but that's okay. And then left leg to middle, it should be 0.5 voltage drop just like the other one, but it reads this. So where we're at now is I need to track down what's causing that because it's killing the output of this MOSFET and it's not allowing the 15 volts to get to the neck board video encoder chip. So that's where we're at now. It's one thing after another. I mean, I went through and tested every diode in the entire chassis thinking that we had a diode problem. I can't find any diode that's wrong causing this. So I went through and checked every resistor along the entire video circuit, couldn't find a bad resistor, but there is something that is bad that's killing the output from this to our neck board. So it's going to come down to trying to figure that out. So that's where we're at. We're going to see if I can get it solved, and once I do, I'll bet you this will work fine, hopefully. But like I say, 1 step forward in finding things and 2 steps back because I find more things. So far we've had, let's see, 2 open resistors. Is that really all we've had is 2 open resistors? I think that's really all we've had is 2 open resistors. Oh, and the HOT that went out. I don't know if I did mention that. It's been so long since I began this video, I can't remember. I think I did mention the FJL series. I think I did. So yeah, the HOT got taken out, which I think happened after I swapped the neck boards because of this open R235. I think this R235 being open is what caused this to get taken out when I swapped the neck boards. I can't say for sure, but we've had 2 open resistors. Yeah, I think that was it. I can't, it's been too long. Anyway, we'll review here at the end. But now the mission is to figure out what's killing this MOSFET in circuit here and try and figure that out. So that's where we're at. Stay tuned. It'll be just a moment for you, but it'll be probably a while for me. So let's see if I can get this figured out, and I'll come right back. Making progress here. Let me show you what I found now. So as you can see here, if we take this and we measure what we were measuring before, where we were getting that short, let's reset our meter here. Now if we go to, I gotta turn this around, stand by. Now if we go to that MOSFET and check what we checked before, the middle leg with the positive, right leg, we had our voltage drop. And then to this leg we had the 0.09 short, but look at it now. Oh, hold on. There we go. There we go. That's what it's supposed to read. We got our 0.5, well 0.4, I round up 0.5 and 0.5. So it's fixed. However, I followed this trace from, I haven't cleaned any of this up yet. I followed this trace from the MOSFET. I took out every single component on the entire trace. I took this component out, and this component out, and this component out, and these two components out, and followed it down and took this component out, and I followed it down and took this component out and this component out. And it wasn't until I removed this leg here, which goes to a jumper. Across here, from here to here, is a metal jumper. And if you follow this trace, it feeds down through to these pins, which are our ribbon cable, which feeds up to our neck board. Now, if I went through and desoldered these one at a time. I desoldered this, and I was still short on the MOSFET. Desoldered this one, still short on the MOSFET. Desoldered this one, still short on the MOSFET. Desoldered this one, and my short went away, as you saw. So with this one not in circuit, my MOSFET reads the way it's supposed to. It is not shorted anymore, and everything's hunky-dory. But of course, I can't leave this like that. So we follow this through. It goes across an inductor here, and that inductor shares a trace here with this component, which is this capacitor, this little C22 capacitor here. Now, if we read that little C22 capacitor on this neck board, it reads 0.114. If we go to ohms, 133 ohms. Okay, fair enough. So let's grab this neck board, and we will read that same little C22 resistor, I'm sorry, C22 capacitor, and if we test that capacitor in circuit, it reads 1.5. So now let's grab another neck board from yet another Polo. This is that one I showed earlier that is a parts one. You can see it's all empty, been picked clean. So let's test. I've even got the resistors missing for the color resistors. Now let's check C22 on this one. This is a bit different capacitor here, but it's the same, should be the same tolerance. So let's check that one, see what it reads. $561. That's very odd. So we have all kinds of weird things going on. I just wanted to point that out. I don't know what that's supposed to read, but we're finding we're on the right track here. So we're gonna have to, it's gonna come down to tracing out which component is on that circuit that is causing that particular issue. So if we follow this around, we know that this being out of circuit will cause our short to go away. And if we look at what that particular pin is, that's the fourth pin over, which is, it doesn't say RG, it says BRG, and then there's nothing printed on the Let's see, it says BRG, and there's nothing printed here for the fourth pin. Oh, interesting. Look at the main chassis here. That's our 12 volts that feeds our neck board. Blue, green, red, 12 volts. Interesting. That's our contrast. That's why we have no contrast, most likely. So our 12 volt input is shorted somehow. The 12 volt circuit is shorted somehow on the neck board. And we got to figure out what it is. So if we follow, I wonder now with that out, I wonder, does this read 10K? No, 900. Interesting. Sorry, I'm talking to myself. This resistor here is supposed to be a 10K ohm resistor, and it's reading 900K in circuit. Out of circuit is 10K, in circuit it's 900K. So I thought that might be something going on here. But it's going to come down to trying to figure out what component on this 12 volt line on the neck board is causing it to short back through into the main chassis. So I'll try and do some testing here, and if I find it, I'll show it off, and then we'll kind of proceed from there. So let's see what I can find on this. Alright, so progress has been made. We fast forward another couple hours, and I think I have solved the problem, and it was pretty much self-induced. Now what I mean by that is that we originally had vertical collapse, and that was caused by a bad R167. We changed that out, and that fixed our collapse, but we had a all-white image. No brightness, no contrast, no color adjustments, nothing. So we went ahead and jumped to the assumption that the LM1203 chip was bad. The color encoder, decoder chip on the neck board was bad. We jumped to that conclusion. And so I went ahead and robbed one from a donor neck that I had and installed it. More specifically, this one right here. The one that's in there now, if you go back and look at the footage, that is the original one that came with this chassis. After this one was installed, we had the issue of still having the all-white image. After that, going through and poking around, that's when I found out that the R40 resistor was open. Of course, this is the donor one. This one here that's bad was off of this original neck board. So we found that R40 was open. Replaced R40, but we kept this chip in there. So after replacing R40, still had the white screen. That's when I began shouting and cursing at the sky and starting more testing, where I went through, and then I ended up finding, what was it, that resistor, R235 I think it was, that was right here next to the HOT that was bad. I found this one that was bad, completely open, replaced it, and still had an all-white screen. So I went through and did more testing, diodes, resistors. That's when I came to the IC105, I think it was. Where did it go? Yeah, I think it was IC105. This one here, the MOSFET that controls the 12 volt to 15 volt change for the 12 volt supply to the neck board, to this chip more specifically. We discovered that it had a shorted output, and I went through and desoldered all of the legs on the chip. Well, first you saw there, I did a few moments ago, I did some testing. None of that actually panned out. So I decided to go ahead and just desolder the legs of this chip one at a time. And when I got to, I think it was, when it's installed there, I think it was pin 6, I think it was, one of these pins. The short went away, and it began reading correctly in circuit. So I took this chip out completely, and I put in this one. This is one, I have two neck boards here. This one here from this chassis, and this one here from this chassis. So I took this one out and put this one in there. Well, guess what? It didn't work either. I started soldering this in one pin at a time. And when I began soldering this in, I got to that same pin and my short came back. I actually had leads on the MOSFET transistor here. I had leads on it, testing it, and I was just soldering one pin at a time. This one, okay, no short. This one, okay, no short. This one, okay. I got to that same pin. As soon as I started that pin in there, I'm sorry. As soon as I soldered that pin in there, my short came back. So now I know that for a fact we have 2 bad chips, if you can believe that. So I thought, well, okay, hell, let's put the original chip back in. I got the original chip soldered back in 1 leg at a time, and it did not short again. So now we have the original chip back in, no more short on the MOSFET. And these 2 that I pulled out of these 2 donor boards just happened to be bad. Now it's possible that they got taken out. Well, this one didn't, because I didn't put this in until after I had already changed that open R04. R40 actually, R40. I did not put this one in until I'd already replaced that. So I think this one was actually bad. I think this one might have either already been bad or got taken out because of the R40 being open. I don't know. But bottom line is we have 2 bad chips. And I put the original one back in. After putting that one in there, my short on the output for the MOSFET is now gone. So I am crossing my fingers here now that this should work. Because if it doesn't, I'm out of ideas. So I have not tried it yet. I'm just hoping that it will work because it should in theory, because with the output of the MOSFET being shorted, we had no voltage getting to our chip. Or we probably would have had voltage, but the chip was bad, shorting out the 12 volts. So now we can go ahead and try it, and we'll see how this works. You have to disregard all this jankery, hackery, because I have just this stuff temporarily set in here like this so I can do my testing. I'll fix it properly later. I haven't done my cleanup yet. I'll do the cleanup. All this stuff off camera I'll do. For now, we're just worried about making sure that this works. So, okay, let's go ahead and turn this on and see what happens here. 1, 2, 3. Okay, that scared me. Why did it take so long? Don't scare me like that. What do we have? Oh, oh yes! Wow. Contrast, yes, full contrast control. Brightness, I have a little bit of brightness control, not a lot. But let's turn contrast down, brightness down, turn our focus up. I'm sorry, screen pot. Let's put it roughly. There's not much control there. But that's okay. Turn that back up. All right. I think right there should work. We are extremely out of focus. Maybe I can adjust some focus here. Oh, hot tamale. Look at that. Let's see. H amp is size. H phase is position. Come on, come on. Oh, fantastic. Well, what do you know, gang? What do you know? Green cut. I need to adjust my green here. Come out of there. There we go. Whoa, too much. There we go. Wow. These colors are all wonky here. It's hard to adjust them because I'm missing the pegs out of here. There we go. Outstanding. Well, another one repaired, and I'm telling you, this was a head scratcher for sure. I do need to make some more adjustments here. We'll do all that off camera, but we have all of our colors. It's working. We ended up having, let's see. Let's scroll through here. Okay. So here's the original flyback, which was working. I think it was actually probably fine, but we changed it out anyway. There was all the old caps that I had taken out. So there's all the old caps, there's the old flyback, and we originally had the problem of collapse, which was caused by an open R167. We replaced it with one, but it was the wrong wattage, and it got taken out pretty much immediately. Then we had an open R40 that was causing an all-white screen. And then we ended up putting two chips in that were bad before or after. that event. And then we found a bad R235 by the HOT. Not sure what this was causing or what the problem was with this. We got that fixed. So we got 3 open resistors, and we had 2 bad video chips. And after a full cap kit reflow and flyback, and we'll make some adjustments later, we have a working Hantarex Polo. And my lord, does that look good. It's hard to see. But the RCA tubes, I've mentioned before, the RCA tubes are just so much far and away better than the Zenith tubes. Man, I'm telling you, this feels good to get this one working. I've been working on this for about, what time is it? About 9 hours. It's taking me about 9 hours today to get this one going. Like I said earlier, when these things fail, they don't just fail 1 or 2 components, they fail spectacularly. So we had 3 open resistors that aren't even related to the vertical collapse. Had nothing to do with the R235 by the HOT going out. It had nothing to do with R40 going out on the on the neck board for the black and white. So we had collapse, a whole separate issue, and then color issues and everything caused by who knows what else. It's just crazy. Why has this got a high-pitched noise all of a sudden? There we go. Not uncommon. So I will get this all taken care of. Maybe I need to do a bit more reflow, I guess, on that. Yeah. I'll get all this butchery taken care of and some more reflow, I guess. When I say full reflow, I mean reflow on anything and everything that visually needs reflowed. If it looks good and doesn't need reflowed, I don't usually touch it. But sometimes when you have issues like this where the flyback is squawking, and I can silence it by doing that, I'll go through and hit some more points. So that's ancillary work. But yeah, we have another successful repair here. Shut up, you bastard. Yeah. Another successful repair. We'll call it good. Of course, I will take this back off the tube and do up my reflow and proper reflow, I should say, with what I just discussed, and give it some more inspection and let it run for its normal 3-4 hours, and we'll call it another successful repair. So I'm not a fan of Polos. They just are always such a pain to try and repair. Case in point here. So I'm just happy we had a good turnout. Stay tuned. There's one more in this series of 4. We're 3 for 3 now. The 4th one is this 7500 that I have here that's got color issues as being reported. So we'll get that taken care of and get that knocked out in the next video. But as you can see, we've got a perfectly working and good looking, needs color adjustments. But we got a perfectly working and good looking Hantarex Polo after all this headache of trying to figure this out. So thanks for watching. Hopefully you'll learn something. I know I do. I always do on these. And follow along on the next series, and we will see how it goes. Much appreciated.